Okay, the next two functions we're going to try to find the limit or evaluate the limit of using graphs and tables are a couple very important trig functions, and we're going to want to memorize these limits because we're going to be using these later when we get into derivatives. So this is very important. So the limit as x approaches 0 of the sine of x over x. Now again, if we substitute, the sine of 0 is 0, and so we end up with 0 over 0, and that's an indeterminate form. So we don't really have an idea what's going on. So let's take a look at this using a graph of it. And this is just going to be the sine of x parentheses. Now I know I'm in radians. I checked that earlier, so that's important. Make sure your mode is radians, and then divided by x. Since I just have a single term in the numerator and the denominator, I don't need parentheses, and I can take a look at the graph. And again, I'm in Zoom 4, so this gives me a pretty good idea. Okay, I could also go to Zoom Trig. There's another window, Zoom Trig, which is over here at number 7. That's Zoom Trig, and that will give this to me in radians, etc. Looks about almost the same. Okay, we can take a look at this. All right, either way. So I'll go back, since we did this in class, and I'll go back to Zoom 4. This is the way we did it in class today. All right. And we'll talk more about how you can manipulate the windows later in another video. Okay, so let's check this. So since we want to see what's going on right around 0, it looks like the limit's going to be 1. Looks like we're approaching 1 from the left and from the right. Okay. So that's a good yes. So let's go to our table set. And let's start, since we're going to check 0, we're going to start at -1. Now, when we're using -1, we use this little negative sign down here, not over here. So that'd be -1. And then I'm going to go increments of 1/10, and I've already got that set at 1/10 from the previous problem, so we're all set. So we're going to start at -1, go by increments of 1/10. So I'll start at -1, -0.9, -0.8, and we'll go over to the second table, or second graph, which gives me that second table. And there we go, -0.9, 0.8, 0.7, and you can see my values are 0.84, 0.87, 0.89, 0.92, 0.94, 0.95, 0.97, 0.98, 0.99, 0.99, and right away we see there that happens at 0. We have the error because that's where it's undefined or indeterminate. And then we can go past that, and you can see how it's pretty symmetrical. I'm approaching 1 from the left and the right. Well, that's what the graph looks like. If we go back and look at the graph, that's what's happening. I'm approaching this value of 1 from the left and the right. You go back and forth and check those. So that's a pretty good indicator, and those are pretty close, pretty good approximations. We're going out several places. Now, if we did want to do like we did before, we can go back, and we can change this so we could go, instead of -1, we could go -0.1, -0.1, and then I would make this change in delta 0.01. So I'm going to, sorry about that. Start this again. -0.1, and then go down here, and I would make that 0.01. So I'd be going by hundredths, starting at -1, and then we go back to our table and see what's going on. So we start at -0.1, and then 0.9, 0.8, 0.7. So we're going to be getting closer and closer by hundredths. So all of a sudden now we are within 1/100th. X is with 1/100th, is within 1/100th of 0. And look at how close I am to 2. I'm sorry, how close I am to 1, pardon me. 0.9998. So I'm really close to 0, and I'm really close to 1. There I have my error at 0, and then I can look at 1/100th, 2/100ths, 3/100ths. So now we're very close to 0. 1, 2, or 3/100ths on either side, in the negative direction or the positive direction, and then we're approaching, okay, 1, very close to 1, and you look on the graph, you can see that how we're approaching 1 from both sides. Okay, all right, so that's a pretty nice one to work with. And again, this is the one we want to remember. So we can say the limit as x approaches 0 of the sine of x over x equals 1. So again, that's one you want to remember. Okay.